Well, hi, I'm Nick Strzakowski, and I'm an associate professor here at Mount Royal University in the departments of biology and general education. Spaceflight is a really challenging environment, and it induces a ton of different physiological adaptations. So one thing, when you're floating around in space, you're no longer loading your feet. You also don't get any feedback about gravity from your vestibular system. So we all have these organs in our head that tell us about gravity and head acceleration, and so that's removed. The loading of the skin on the footsole is removed, and so that leads to sensory motor adaptations. The current project is one small piece of a much larger research program in collaboration with NASA, the Canadian Space Agency, and the German Space Agency. The main objective of this program is to look at countermeasures that might help astronauts in space to mitigate some of the risks that they face. The project I'm involved in is looking at changes in footsole skin sensitivity, which is just one piece of this larger project. So big picture, this research is interested in astronauts, but space research is dangerous and expensive and complicated. And so we have to develop analogs to do some of this research here on Earth. And one of these analogs is long duration bed rest. So what we're doing in this project is having participants lie in bed with their head tilted down below their feet about 6 degrees for 60 days. And this simulates many of the physiological challenges that astronauts face in microgravity. So this results in unloading of the feet, they're not using their muscles, we have bone demineralization, we have fluid shifts, so blood flows towards the head. These are all things that we see in astronauts in space, which we can simulate here on Earth. To maintain standing balance, we use a variety of different sensory cues. So we use our vision, we use our vestibular feedback, and we also use tactile feedback from the soles of our feet. What's interesting is we have 4 different kinds of these receptors in our skin that tell us about this touch. And so this research is going to look at how those specific skin receptors might adapt and change under this unloaded 60 days of head down bed rest condition. What's really interesting about this project is that there's both basic science questions that we have just about human physiology broadly, how does the body change in these challenging environmental contexts, but also what can we do practically to help astronauts mitigate these risks that they face. And because astronauts are humans, anything we can learn about human biology may have spin-offs, and often do, to help humans here on Earth. Many people have balance impairments, have sensory motor impairments as well, and so this research may help with folks who suffer from balance and sensory impairments here on Earth.